Hello, everyone. This is Romy Christoph, and today I would like to show you the homework and the assignments for the next week. Um, so you need some explanation because the lab class is difficult online, and I just like to make it easier for you. So this week, week two, you have our sun relationship. You have the sun angle here. I think that it's pretty clear everything. Now we'll concentrate on week three, and we'll go here to the temperature graphs. So let's go to this one first. Here in the text, please read what it says. You have to create a temperature graph, and let's go to the page first and see what it says. Okay, so as you see here, there is a table, and here are the months of the year from January till December. You have station 1, station 2, and station 3. So these are three columns where you have the average temperature of the month. You have a graph here for San Francisco, as you see, it's already done. And what do you have here on this scale? You see here the numbers on the left side in degrees Fahrenheit temperatures, and you see here the month of the year from January till December. How do you construct the graph? Above each month, you have to put the temperature. Let's see, here are the stations. Station 1 is Norfolk, station 2 is San Francisco, which is already done. The graph is already done. And the third one is St. Louis. Let's go to Norfolk, which is number 1. And let's see here for station 1 what it says. January has 40 degrees temperature. So you come here above January, you find 40 degrees, you put a dot. Then for February is 42. You come here to February. Above February, you look on the scale where 42 is. So you're going to put another dot. Then you go to March. March is 49. You come here above March, you will find 49. You put another dot. And this is how you go all the way till December. And then you connect all these dots like it's done here for San Francisco. And the graph shows you how the temperatures are changing throughout the year from January till December. You can use different colors or different patterns and put them here in the legend to show and label the graphs to see which one is Norfolk, which one is St. Louis. And then you have to find the temperature range for each station. The temperature range is the maximum minus minimum temperature. So the highest minus the lowest number. So this is for the first graph, the first graphs here. Then we go here to the second table. There is station 4 and 5. And for these stations, which are here, you have here Iquitos in Peru and Quito. Also, you do the same thing. You have to create here the two graphs on this scale using the numbers on the left side. These are the temperatures in Fahrenheit. So this is what you have to do about the temperature. This is the only page what you have for the temperature graphs. You have to learn how to do that. Then we'll go to the second assignment, which is about pressure and wind. And I would like to show you here the pages, what you have, and also the PowerPoint presentation. Let's open the PowerPoint presentation and see what it says. Okay, so before you start working on your pages, you definitely have to go to the PowerPoint and to learn how to do everything. So here on this slide, you see that the air has weight, and some places they have more air molecules, concentration of more air molecules, which creates high pressure toward the surface. In some places, they have less air molecules, which creates a lower pressure. So in the nature, there is always a balance, and the winds actually a result of the different pressure. And here it says, this is a horizontal movement of air produced by differences in air pressure from one place to another. So the winds always blow from high to low pressure. You see, this is a map where you have the high pressure cell and the low pressure cell. And these are the isobars, the lines connecting points with equal pressure. So always the winds blow from high to low pressure in attempt to equalize the pressure on the surface. And let's go here. Many people, they cannot make a difference between onshore and offshore winds. The onshore winds, they blow from the ocean, as you see, toward the land. And of course, they carry moisture from the ocean. So they're usually wet winds, right? They bring moisture, they bring clouds, precipitation. And this is the windward side of this island. On the other side, you see the winds are offshore, which means they blow off the shore from the land toward the ocean. They usually dry because they come from the land, so they don't carry much moisture. This is part of your homework assignment. You have to complete the land and the sea breezes. We live close to the coast, and you know that the winds, they change their direction during the day and night, and this is because of the different pressure on the over the ocean and over the land. So when you do the land and the sea breezes, you have to first find where the colder air is. The colder air is heavier and it's associated with high pressure. The land is warming up and cooling down faster than the water. So during the night, you see this is a night picture. Over the land will be high pressure because the land will be colder than the water. Over the water will be the low pressure. And you have to label the land and in the ocean with the H and L, high and low pressure, and to put these arrows pointing the direction of the wind from high to low always. What happens during the day? During the day, the land is warming up very fast. So the low pressure will be created where the warm air is, and over the ocean will be colder, so the high pressure will be there. So these are the sea breezes. They blow from the ocean toward the land, and they create this pleasant conditions during the summer. So this is something what you need for your homework assignment. So that's why I would like to show you the PowerPoint and to show you where to look for the information when you start working on your pages. Now here are the valley and the mountain breezes. Um, so here again, we have to look where the high and the low pressure is. We have to label the places and to point to put the arrows to show the direction of the wind. During the day, imagine you're in the mountains. These are the high slopes and the peaks there, which are close to the sun. So they're getting warm very fast, which creates low pressure there. So the air is rising. When it's warm air, it's rising, creating low pressure close to the surface. At the same time, at lower elevation, it's still colder. So the sun rays, they didn't reach this place. So this creates this valley breezes because they come from the valley, from the lower elevation, from high to low, you see toward the um, higher elevation. And that's why they're called valley breezes. During the night, so the sun is gone and all these slopes here, they're getting cold very fast. So this is high elevation also. So they're very cold, and that's why there is a high pressure there. At the same time, in the valley, it's still warmer, and the cooling process is very slow there. So this creates the low pressure there. And as you see, the winds blow from high to low again. So this is another um, two pictures you have to use for your pages, for your homework. Let's see here the situation in California. You live here and you know that we have two seasons. We have summer and we have winter. So how do we explain the seasonal shift of the winds and why the winds they change their direction during the winter and summer, and we have different weather conditions. So we're in the high pressure belt. So, here is the Pacific high. You see Pacific high pressure cell. In the high pressure cell, the winds blow clockwise from the center toward to the periphery. So here is the highest pressure in the center. So during the winter, this Pacific high pressure cell is located over the ocean, and this creates this onshore winds. You see, the winds blow clockwise and they carry moisture toward the land. So these are the westerlies. And that's why we have more moisture during the winter. During the summer, you see the Pacific high pressure cell is moving toward the land. So it's located over the high desert. And the winds, again, they blow clockwise in the highs, but they're offshore. And you see, they create very dry conditions because they come from the desert. So here we include the Santa Ana winds also, which are offshore winds. So these two pictures also you will need to explain your page. Here is the page. So we already talked about the sea breezes. You see here on the left side, you have directions, what you have to label. Now this is the night picture for the local breezes. You see the ocean and the land. This is the day. You see the sun, the ocean, and the land. So these two pictures, you will label there the sea and the land breezes. The first two pictures, what I showed you. Then you come here to the mountain breezes, mountain and valley breezes, number 3 and 4. Again, you see the night picture and the day picture. You have to label the high and the low pressure in all these pictures, and with one arrow to show the direction of the wind from high to low, always. Don't forget that. The winds, they never blow from low to high pressure. And here, picture 5 and 6, this is about the last two pictures. This one here, the seasons in California. So this is actually what you have to create. This is the first page. Then we go here to the monsoons. So these are seasonal winds, like the winds in California, in Asia. But there is an opposite seasonality of rain. So during, you see, here is July. During the summer season, the low pressure is over the land and the high pressure is over the water, which creates onshore flow. And these winds are very wet, and they create lots of moisture. They bring heavy rains to these countries which are located in this part of the world. During the winter, you see January picture is opposite. So the high pressure is over the land, which creates offshore winds. What you have to do in your pages, you have to label the missing high or low pressure cells. They can be over the water or over the land. So you see here, the high pressure is over the water, the low pressure is over the land. Here is the opposite. And you have to put also the arrows in your homework to show the direction of the wind. Let's see, these are the maps. And here are the instructions. So read carefully what you have to do. You see where the high pressure is? It's over the land. So where are you going to put the L? You will put the L here over the water. You follow the arrows. You see the winds blow from high to low. So you follow the arrows and you have to put an L here. On this picture, you have to put the high pressure to locate the high pressure. So you see the low pressure is over the land. Again, follow the arrows. You have already one high pressure cell here. You can put one here, for example. Also, you have to create here a title for each one. You can use these pictures, the monsoons during the summer or during the winter. There is here, there are some suggestions here what you can do, how to label everything. Just read carefully the text here on that side. So this is, and the last one. So this is also your page, the last one, where you have to create a climograph. You have to create here the precipitation. So we did temperatures separately. Now we're gonna do a climograph where you will put the precipitation rates. There are two stations here. One is Sacramento in California, and the other one is Cochin in India. India is in this monsoonal zone, and we have to actually create this bars. You see here there is an example for each month, like we did for the temperature, using the scale on the left side. This is in inches. The numbers are in inches about the precipitation. For each month, instead of a dot, you create these bars. And these bars, they will show you how the moisture is changing from January till December throughout the year. And then here are the questions actually about comparison between the two stations. And you have to prove that they have opposite seasonality of rain. Another thing I would like to show you from, okay, this is the summer. You see in red the month January, February, March, then from April till September, these are the summer months. If you have to find the precipitation during the summer, so you have to add all these numbers. You see, you have here S is for Sacramento, C is for Cochin. For each month, you have the precipitation rate, and you have to put it here. Also, you have the year precipitation. Read carefully the questions and follow the instructions. It says how to find everything. You see, take winter 24, question 24, divided by the total precipitation 22 times 100. You see, you have to read carefully, and it says how to find everything. So you have the rates here. For each station, you're going to use this rates in the from the table, and you use the scale here, the numbers in degrees. Above each month, you have to construct this bar. So the height of the bar is actually the rate, which is shown here in the table. So this is actually what you have to do. Here are the pages. You see, this is the PowerPoint presentation, what I just show you. Let's see what else you have. You have moisture. Let's go to moisture, and let's go to the PowerPoint presentation. So you see that the PowerPoint presentations, they contain your pages, and they will help you. They give you some tips, some explanations, some examples you can find, and you can find, of course, your pages. I make many changes all the time. I can change the numbers or slightly to change some questions. So you have to follow only the pages which are listed in your assignment for your module. You don't have to copy anything from the PowerPoint presentation. So these are just the examples what you can use. Now, we're going to talk about the humidity. Humidity shows you, as you see, the amount of water vapor in the air at any time and place. So here are some of the terms what you have to know, because you have to do some calculation. What is the capacity or saturation mixing ratio? So everything has a capacity. A room has a capacity, right? This is the mm, uh, maximum water vapors the air can hold. This is the capacity. The warmer the air, because the warm air is expanding, it has more capacity. Usually the cold air is squeezing, it has less capacity. When the capacity is full, there is no more space in the air for water vapors. We say that it's reached the state of saturation. So this is capacity. So the higher the temperature, the higher the capacity. Content or mixing ratio is the actual amount of water vapor in the air. Then you have the dew point temperature. So to start the condensation process, this involves a cooling uh, conditions, cooling process, and cooling of the air. And the dew point temperature actually is the temperature at which the saturation starts or the condensation process. So when the clouds, they start precipitating, this is the condensation. Relative humidity is a ratio. So the content over capacity times 100. This is the formula. And let me show you here. You have an example how to calculate the relative humidity. You see, content over capacity divided by capacity times 100. And you get the number in percentage. This is the air in these examples holds 67% of its capacity. So the relative humidity shows you the percentage of the air which holds water vapors. And I gave you here one example how to calculate everything. You just follow the formula and you replace the numbers, your numbers in the formula. So this is here the graph which shows you that the higher the temperature, the higher the capacity. You don't have to do anything with that. Here, it's a very good example. This is the relationship between the content and the capacity. So you have 3 glasses, and actually the size of the glasses shows you the capacity of the air. You have the temperature in Celsius. You see 5 degrees, 15, 30 degrees. So this way the temperature is increasing. And what happens with the capacity? You see, the capacity is increasing also. This is the size of the glasses. The content everywhere is the same. So what about the relative humidity then? You see, the higher the capacity, the lower the relative humidity. You see, here is 100%, which means the capacity is full. There is no more space for water vapors. So this means 100% relative humidity. So the higher the temperature, the higher the capacity, the lower the relative humidity. So this is something important you can go through again. And here is your page. So I told you that you may have different numbers, but let me show you what you have to do. So first you have here all these terms, what you have to know and how to find them. Then you have here a table. The table shows you the temperature and the capacity. If you know the temperature, you see, you will work in Fahrenheit, so you will concentrate here in this column where it says temperature Fahrenheit. If the temperature, for example, is 15 degrees, you will find the capacity here in the table. It will be 1.9. If the temperature is 40 degrees, the capacity will be 5.2. So the temperature and the capacity you will find from this table. If you know the capacity and you want to find the temperature, you come here, let's say the capacity is 9.3, and you want to find what the temperature is. You go this way and you find that 55 degrees Fahrenheit is the temperature. So what do you have here? You have the relative humidity formula. You see content over capacity times 100. This is how you will find the relative humidity in percentage. Now here, the air temperature is 70 degrees Fahrenheit. The relative humidity is 60%. I think that you have different numbers. They are not the same like here in the PowerPoint presentation, but you follow your page, not this one. You just take a look how everything works. But actually, you will use your numbers in your pages, which are listed in your module. So let me show you here with these examples how this works. It says that the air temperature is 70 degrees and the relative humidity is 60%. What is the capacity? So you come here to find the capacity, you have to use the table. The temperature is 70, right? Here it is, 70 degrees, so the capacity will be 15.6. So you're gonna put here 15.6. What is the content? Now, the content and the relative humidity, you will find replacing the numbers in the formula. You know that 60% is the relative humidity, so you can't calculate in percentage. You put 0.60. The content is X divided by capacity. So capacity will be this number here, what you found, and just do the calculation and you will the content, the X. Then it says dew point temperature you have to find. There is no formula, no way to find the dew point temperature. It includes a cooling process, but it says here what to do. Take the content and match it to the temperature. So instead of capacity, here in the table, you will use this number, the content, what you find from the formula. You come here, you use these numbers to find the temperature. So the dew point temperature will be lower than this one. And it says how many degrees does the room have to cool to achieve the saturation. You just subtract the two temperatures, 70 degrees and the dew point temperature, let's say it's 55, you subtract them to find how many degrees does the room have to cool. Everything else, you will read carefully. It says where to find the numbers and how to calculate them. So this is just read carefully and complete the rest of the assignment. So here you have two tables where there are some missing numbers and you have to do the calculation. For example, you have the content here, temperature, capacity you have to find. Temperature is 20. You come here to 20 degrees. You don't have 20, but you have 21. So the capacity will be about this number, about 15, right? You put here the number. Then you do the calculation to find the relative humidity. Use the formula. Content over capacity times 100. If you know, this is for Celsius. You see Celsius temperatures, and this is Fahrenheit. So in both tables, you have to complete the missing numbers. You have to put the missing numbers using the table for the temperature and capacity, or the formula if you have to find the content and the relative humidity. So this is your page here. Let me close it. And let me go back to your assignments. You see temperature graphs, winds, and moisture. Actually, this is all what you have to complete. Remember, I told you that in the discussion forum, you can communicate, you can compare your answers or help each other. And also you may have some questions. You can earn some extra points over there if you answer the questions shortly. So let me go back here. And that's it. I wish you good luck. And you guys can call me, can actually send me a message anytime. Please use my help. I wish you good luck. Okay.